Hello everyone, my name is Lily. I'm from JaxonMining. It's my great pleasure to give a talk at Rock Talk. I would like to introduce our flagship project, Natazo Mountain. It's a high-grade polymetallic bin-type project in Skin Arch area. Today, I'm going to briefly introduce a structure-controlled deposit type and the mineralization model of the Natazo Mountain project. Natazo Mountain project is located 40 kilometers northwest of Smithsonian. Jackson's field geologists were very lucky last year. We found a few artisanal working areas. There are no government records of those historical workings. Natazo Mountain was prospected by Marshall Lavenza with Noranda Mining about 50 years ago, but since then, there's no systematic exploration until 2019. Natazo Mountain project is one of the 4 projects in Hazelton property, which is 100% owned by Jackson Mining. Other 3 projects are Red Spring, Blood Mountain, and Max. Red Spring and Blood Mountain are 2 porphyry copper moly targets. Max and Natazo are 2 high-grade polymetallic bin-type targets. On the geological map, the pink represents the intrusive rocks. As you can see, there are 2 big intrusions on the Hazelton property. A big one is on the left side, which is associated with mineralization in Red Spring and Max. Another one is on the right side, which is associated with mineralization in Natazo Mountain. So today we're going to focus on Natazo Mountain project. As you all know, buccal intrusions are very important for mineralization at BC as Skin Arch area. Historical dating data of buccal intrusion are 60 to 84 million years old. We also did dating study for our intrusions at Red Spring and Natazo Mountain. All the images are showing the dating samples we collected from Red Spring and Natazo Mountain. We collect 9 granodiorite sample and 2 molybdenite sample from Natazo Mountain area. Both intrusion and mineralization return similar age. They were formed in age of 62.9 to 64.3 million years old, which is in Paleocene. We collect 4 granodiorite sample from Red Spring area. The zircon dating indicates those intrusive rocks formed at 66 to 67 million years old, which is in late Cretaceous. The intrusions at Red Spring and Natazo Mountain formed during 2 different episodes of buccal intrusion magma, with a time interval of approximately 2 to 3 million years old. The next 2 slides showing the dating result from zircon and moly. On the geological map on the right side, the yellow star represents Natazo Mountain, blue star represents Red Spring. The intrusion age at Natazo Mountain is around 63 million years old. Intrusion at Red Spring is around 67 million years old. There is another intrusion located to the west of Red Spring. We found another data about 72 million years old. So you can see from the west to east, the intrusive age is getting younger, which probably indicate eastward migration of coast range continental arc magmatism. Last year, Jackson conducted soil sampling, rock sampling, and aeromagnetic survey programs at the Natazo Mountain project. Both rock sample and soil sample return very good anomalies. According to those anomalies, there are 4 mineralization zones have been delineated. The first is Daisy North Contact Zone, and second is Daisy Central Zone. Third is Daisy South Eddy Zone, and fourth is Daisy East Zone. This is an airborne magnetic anomaly map of Natazo Mountain project. On the map, pink represents magnetic high and blue represents magnetic low. Both high-grade rock sample and soil sample are plotted in the magnetic low area, and the magnetic low anomalies are associated with polymetallic mineralization. which integrating the hydrothermal fluids, result in magnetic destruction. Magnetic low anomaly shows the linear feature, which are probably controlled by the fractures. The white line in the map represents the infrastructure, and the structures are quite well developed on the Natazo Mountain area. Magnetic node anomaly also occur at the contact zone between intrusive rock and sedimentary rocks, which is consistent with Daisy North contact zone. Last year, Jackson's work focused on north part. An even strong magnetic destruction area occurring in the southeast part. So far, no work has been done in that area. So Jackson's team will do more exploration work on that area this year. This is the Daisy North contact zone. The left side is home-filled latite, and the right side is granite. The whole zone is up to 12 meters wide. It contains a few high-grade polymetallic veins. You can see this sample is grabbed from this area. So extremely high grade. It contains 5,300 gram per ton silver, 38% zinc, 30% lead, 3.3% copper, 2.3% antimony, and the whole contact zone is up to 1 kilometer long. We also did soil sampling in this area. The highest copper grade is more than 1%. We also did the petrographic study on the veins. So multiple phase vein stage has been recognized. The early stage is coarse veins with massive sulfide with the tetrahedrite, the yellow color, and the sphalerite, the gray color. And second stage, some samples contain the galena, and also third stage is chalcopyrite. You can see the yellow color, small chalcopyrite veins and strings. The last stage is calcite veins. The cores in the vein are quite large and euhedral, as shown in this image, which indicates the crystal grow in a free space environment. We also did chemical study on tetrahedrite and sphalerite. The tetrahedrite is rich in silver, and the sphalerite is poor in iron. These are two pictures taken from Daisy South Zone. We found two adits in the Daisy South Zone. The left image shows the audit 1. The right image shows the audit 2. In this zone, there are multiple coarse veins. The coarse veins are quite rich in sulfide. The width of the veins is about 2 to 5 meters wide. There are also a few centimeter coarse veins in this zone. The highest grade chip sample contain 1,600 gram per ton silver, 5.9 gram per ton gold, 3.4% copper. We also did soil sampling in this area. The highest grade of the soil sample is more than 100 gram per ton silver, and 8,450 ppm copper, 3.7 gram per ton gold. The left image was taken on the top of the ridge, which showed the fracture zone that control coarse veins in AD2 area. The fracture zone is up to 1 kilometer long, and the elevation difference from the top and the bottom is about 300 meters. And the right image was taken at the bottom. You can see the fracture zone is quite obvious in the field. A bunch of coarse veins, mineralized coarse veins, are contained in those fracture zones. We also did fluid cushion study. We tried to get the temperature of hydrothermal fluids. The left image is a coarse vein with fluid cushion from audit 1 zone. The fluid cushion temperature are 267 to 340. The right image shows the coarse with fluid cushion at an audit 2 zone. The temperatures are 290 to 361. The temperature is quite high. We usually think the system is epithermal, but it should be mesothermal instead of epithermal. This left image is taken from Daisy stone. You can see the alteration in the granite. And the right image can show the whole project. We are looking to the south right now. You can see the Daisy North Zone, Daisy Center Zone, Daisy South Zone, and Daisy East Zone. Those are the pictures taken from Daisy East Zone. The vein stockwork found in the Daisy East Zone is shown in the left image. The clay alteration is quite obvious, which is shown in the center image, and also some sulfide-rich coarse veins, which shown in the right image. A great sample of the coarse veins return gold of 1.2 gram per ton, silver of 361 gram per ton, copper of 1.3%. And we also did a chip sample on the coarse vein. We returned copper around 2%, silver around 75 gram per ton. We also did backscatter electron image and zinc section study on the coarse vein at the east zone. The left one is a BSE image, which show a mixture of malachite, hematite, limonite, which is indicating a very cool down process of the mineralized hydrothermal fluid. The right is a zinc section image, which showing hematite, chalcopyrite, malachite, chalcocite, and limonite. We also did the cone trace element study. As you can see, the red dots and the blue dots from Red Spring and Natazo Mountain are all plotted in the fertile area, which indicate a big potential for the porphyry system. For the oxygen fugacity, the red dot represent samples from Red Spring, blue dot represent samples from Natazo Mountain. You can see red dot and blue dot are totally separate. The samples from Red Spring are relatively reduced, and the samples from Natazo Mountain are relatively oxidized, which represent two different episodes of the Barkley magma. The core temperature are from 650 to 750, which are typical porphyry magma temperatures. Natazo Mountain project occurs in a porphyry epithermal system. Although the fluid inclusion study shows the temperatures are higher than typical epithermal type, Natazo Mountain share a lot of characteristics in common with intermediate sulfide epithermal deposit, such as stability of chalcopyrite, silver-rich tetrahedrite and tennantite, manganese-rich calcite, iron-poor sphalerite, like in arsenopyrite and pyrrhotite. All those features have been found at Natazo Mountain project. So we consider the Natazo Mountain as an intermediate sulfide system. This image is a typical epithermal and porphyry system. Cause the fluid inclusion study shows the temperature of hydrothermal fluids are from 300 to 350, which is quite high than the epithermal deposits. We consider it occur at the transition zone between porphyry and epithermal. It's a typical intermediate sulfide system. Cause we found clay alteration and windstalk work at Daisy East Zone. We consider Daisy East Zone occur close to porphyry center. Natazo Mountain project has high potential for exploration. Natazo Mountain project is located in Skin Arch area. It's associated with Barkley intrusion. Late Cretaceous to Eocene intrusive rocks are quite rich in mineral. As you can see in the left image, the yellow color and orange color represent late Cretaceous to Eocene intrusive rocks. A few big porphyry and epithermal deposits are associated with late Cretaceous to Eocene intrusive rocks, such as Darling Creek, Papal, Blackwater, and Huckleberry. Recent deep drilling results from Huckleberry mine confirm existence of deep copper porphyry deposit in the Skin Arch area. Natazo Mountain project is also occurring in porphyry system in Skin Arch area. We believe there is a possibility to discover porphyry type mineralization at depth and Natazo Mountain area. Compared in age, lithology, alteration, and structure, Natazo Mountain project could be analog to Blackwater and Huckleberry. Just in a word, we believe Natazo Mountain project has high potential for exploration. Natazo Mountain project could be analog to Blackwater deposit. This slide shows all the characteristics that share in common between Natazo Mountain and Blackwater deposit. Both are intermediate sulfide system. Both have similar age. Both contain high-grade polymetallic veins. Both contain magnetic anomaly. Both occur in porphyry system. Both have similar mineralization temperature. We believe Natazo Mountain will develop into Blackwater-sized deposit in future. Our Natazo Mountain area is early stage exploration project. We still have a long way to go. Any comments and suggestions, welcome to contact me, Tony, and Joe. Thank you.